We're wrapping up a cold January where most of us got to see at least a little bit of snow over the course of the past couple of weeks. We'll be recapping those events today, plus, we'll have a discussion on how you can contribute to the success of our radar and warning program as we head into severe weather season by becoming a trained Skywarn storm spotter. I'm meteorologist Matt Stolley at the National Weather Service in Fort Worth, and we are on air. Good morning. It is Tuesday, January 28th, 2025. Thank you so much for being here. It is episode 3 of the On Air podcast, and let's face it, it's been a minute since we've done one of these. Between the holidays and some active weather, it's been a struggle to find the time, but we're back, and how about a belated New Year's resolution? Let's make it a point to try to do these a little bit more frequently this year. But thank you so much for being here and joining us today. We'll be recapping a cold January with our couple of snow events that we've had so far this month. Plus, we've got a double dose of radar recaps. We'll be looking at one of those snow events, plus a severe weather event that we had back last December on Christmas Eve, actually. And we've also, speaking of severe weather, we aren't that far away from severe weather season, just around the corner here in the spring. So we've got Jennifer Dunn coming on, who is our warning coordination meteorologist here at the Weather Service in Fort Worth. And she's going to be talking about our Skywarn Storm Spotter program. So if you are looking for a way to get more involved with reporting severe weather and learning more about it, stay tuned for that segment because we're going to talk about how you can become involved and contribute to the success of our radar and warning program. So we've got a great episode for you today. Thank you so much for being here with me. I want to get to the cold month of January that we've had. A couple of good Arctic air intrusions, which is not uncommon from a teleconnection standpoint, given it's a La Nina winter. So we do tend to see some pretty good Arctic air intrusions during those types of winters, and this January's been no exception. We started the month above normal, so on this particular graph, these bold lines are the observed temperatures from DFW so far this month, and the thinner lines are the normals, and then the records are these outliers up here on the top and bottom. So we started off above normal, and then got a really good cold front there for the second week of January. That's where we had our North Texas snow event earlier in the month. Followed by a return to kind of mild, near normal weather during the middle portion of January, and then our big cold front just last week, where we had another snow event, mostly in central Texas that time, and spent several days with below normal temperatures, lows in the teens and 20s over most of the area, and highs only making it into the low 30s for most of us. So a pretty seasonably cold January, and a couple decent snow events for us, which is hard to do in Texas. That first event back from January 9th, saw some really impressive snow totals by at least by North Texas standards. It's hard to get 6 to 8 or even 10 inches of snow like we saw with this event, but we did manage to do it. Areas in the Metroplex or from the Metroplex northward all saw accumulating snowfall. Amounts within the Metroplex itself ranged mostly from about 1 to 3 inches, but they quickly increased as you moved northward towards the Red River. We had a handful of reports that were 6 to 8, even 10 inches in places. This one here on the left is from St. Joe. They had 6.5 while it was even still falling. This one in the middle is from the Sherman-Denison area where they had already picked up 8 inches of snow. And then we had Daniel Hayes here in South Denton who sent us this awesome snowman that he managed to build, which is really impressive for being able to build a snowman that's that tall in North Texas with a snowfall event. He later referred to this six-pack ab snowman as the abdominal snowman, so I really got a kick out of that. It was one of my favorite reports I saw with this event, but thank you so much to everybody out there that sent us in their snowfall reports. Without those, we don't truly know how much has fallen in any given location. We can obviously see the snow on the radar, but we don't know any of that ground truth information about how much has actually fallen until you send us your reports, so we appreciate each and every one of them. Now, while it was certainly an impressive snow event for North Texas, we were really only a degree or two away from making this event something that was truly historic. So you probably remember that we spent most of the afternoon and early evening hours on January 9th with mostly just rain. We had a transition from this event where we started off with a rain sleet mix and then went fully over to rain for the bulk of the afternoon and early evening before transitioning fully over to snow later in the evening and overnight. And that was due to basically just being about 1 to 2 degrees above freezing. So this is our weather balloon data from 6 p.m. on 9th over here on the left. And I've got the blue line denoted here, which is the freezing line. The right line on here is our temperature. The left line is the dew point. So we are saturated where those two lines are very close together all the way up for the bulk of this balloon sounding. But you'll notice down here in the lowest 6,000 to 7,000 feet that we were just barely above that blue freezing line. That's just about 1 to 2 degrees Celsius. And that was enough to melt pretty much all of that snow that was being generated up in the middle portion of the atmosphere up here. It was enough to melt it on its descent to the surface just by being 1 to 2 degrees Celsius. So that 1 to 2 degrees, that incredibly fine line, is all that it takes to transition this from a rain event to a snow event. And the rainfall totals, the liquid equivalent totals across North Texas with this were almost all over 1.5 inches of liquid. And you can imagine if you convert all of that to snow instead, a typical rain to snow conversion ratio is about 10 to 1 on average. So some quick math there says that 1.5 inches of rain is going to be well over a foot of snow. And we were only about 1 degree Celsius too warm to convert all of that rain into snow through the entirety of this event. So if you're like me and you want to see some snow once in a while, it was a little disappointing because we were just so close to making this event almost a once in a lifetime opportunity to see maybe 1 to 2 feet of snow somewhere in North Texas. Just a degree is really all that matters. And that's what makes forecasting these kind of events so challenging, is that just a degree or two, a few thousand feet off of the ground, makes all the difference. So you can see what happened over here on the right. This is our balloon sounding from 12 hours later, and we did lift and cool that layer by that point. So this was the tail end of the event when things were tapering off. We were all well below freezing by that point, all the way through 5,000 to 6,000 feet above ground, but you can see what happened to our saturation. Our temperature and dew point are super far apart up through the mid-levels. We have top-down drying going on and some subsidence moving in instead of ascent. So by this point, we were just left with some light snow being generated down in this much more shallow layer. And that was that tail end of snow that produced just kind of that trailing 1 to 3 inches of snow across parts of North Texas during the late evening and overnight hours heading into January 10th. So again, those are the really fine details that go into forecasting something like this, and that 1 degree really makes all the difference. Now, we followed this event up with a second one about 10 days later in Central Texas, and this was the same storm system that brought snow to the Texas coast and then over into Louisiana. Certainly a historic snow event for those areas for sure. But most of our Central Texas counties did manage to see at least some snow flurries and even a little bit of accumulating snow in some places. So a few more photos, anywhere from Waco down to Bryan and College Station, which is on our southeastern border. Pretty much anywhere kind of along and south of I-20 managed to see a little bit of snow, while North Texas was simply too dry. And we're actually going to take a look at this for our Q&A segment in this episode. And during this event, when we had snow down in Central Texas, we had sent out this radar tweet, and we instantly started getting sort of all these questions and comments about how there's this big circle right over the Metroplex. The snow's trying to avoid DFW again. It's missing the city. It's going around us like it always does. But that's not exactly the case. That's not really what's happening here, and that's not what the radar is really telling you. So I thought, what better opportunity to take than to address this in our Q&A segment this week. So in order to know what the radar is telling us, we've got to know something about the background environment first. So this was the scenario that we had. We have a very thin cloud layer up near 3,000 feet, which is comprised entirely of snow. It's well below freezing, so there's no issues there in terms of temperature. And you've got light snow that's falling out of that cloud layer, but it's encountering all of this dry air down beneath in the lowest few couple thousand feet of the atmosphere. So all of this snow that is trying to fall out of this cloud layer over here on the left-hand side of our radar is basically just sublimating. It's evaporating into thin air long before it is able to reach the ground because it's encountering that dry air and it's just turning back into vapor. Now, if you have enough saturated air down near the ground layer, you can actually get that snow to survive all the way down to the ground. So the weather across most of our area here on this schematic is pretty uniform, with the exception of this one little pocket of saturated air over here on the right. So now, how is the radar going to view this? Well, so these red lines here are going to be our radar beams. And remember, the radar isn't just scanning one time around. It is scanning the lowest level, and then it's tilting up and it's scanning again, and then it is tilting up again and scanning around again. So also remember that radar beams are not flat and horizontal. They are all at angles, and they are scanning upwards and outwards away from the radar. So think about the trajectory of this lowest radar beam here in red. Well, what is it actually encountering for this first part of its journey? Well, it's scanning completely clear and dry air, right? It's actually missing this cloud layer and any of this snow that's falling out of the cloud at this point. So the radar is not going to detect anything right here because the radar beam is scanning below the cloud layer. Now, at some point, as it journeys far enough away from the radar, since it's tilting upwards at the same time, eventually it is going to be high enough to start encountering that sublimating snow and that cloud layer, and it's going to provide returns. So I'm going to mark the actual radar returns in yellow on here. And those are really the only points where the radar is actually going to show precipitation that's occurring, because it's the first time that the beam is actually encountering anything to return energy back to the radar again. So you can see that even though our weather is exactly uniform in terms of what's occurring, which down at the ground over here on the left side is absolutely nothing. There's no precipitation falling at all. So the radar very near to the radar is going to show absolutely no returns, and it's going to start showing echoes as you move farther and farther away, just because it's higher up and it's finally scanning that sublimating snow and that cloud layer. But notice what also happens when you tilt the radar upwards, when you start going to those higher elevation scans. Well, if you're tilting up faster, you're going to start encountering that cloud layer and that snow faster. So it's actually going to look like the snow is moving closer to the radar location as you tilt upwards in space, because now here we're encountering the snow sooner, and if we tilt up again, we're encountering the snow even sooner yet. So you can't just sort of use that lowest radar scan, which you're very used to seeing. Most apps are just going to show you that lowest radar scan, but having the ability to tilt upwards and look at those other elevations is critically important to be able to really truly understand what's unfolding in the atmosphere. So let's take a look at what's going to happen on the right side of the radar now. So as we're scanning outwards and upwards away from the radar, those returns are actually going to be pretty much identical to the left-hand side, because we've got the same thing going on. This lowest scan is still not going to encounter any snow until it gets over to this area before it starts finally sending returns back to us. So even though this is our one pocket of air where it's saturated enough to actually support snow, the radar is actually going to look identical. It's almost going to be a mirror image to what's happening over here on the left-hand side, even though our observed weather at the surface is very, very different. Over here, there is absolutely nothing falling, and over here, this lucky individual at their house is actually seeing a little bit of snow. So it's not enough to just glance at the radar and be able to determine what's happening down at the ground. You've got to have some background knowledge of your environment to truly understand what's unfolding. So this is our actual weather balloon data from this event. And this blue box here, that's that cloud layer that I was talking about on our previous little drawing, where we have this kind of thin saturated layer, but look how dry the air is. Our temperature and dew point are super far apart down here in the lowest kilometer. We've got a temperature and dew point spread of over 30 degrees down here at the surface. It's way too dry for any light snow to be able to survive that trip all the way down to the ground. It's all going to sublimate on its journey to the surface. So if we go to our weather balloon 12 hours later, you can see that now our cloud layer, it has descended a little bit, but it's super thin. We've basically shut down the lift at this point. we hardly have anything to really even generate precipitation other than some very light snow at this point. And we have saturated our lower levels because as all of that snow sublimates, it is going to contribute to raising the dew point in that little layer down by the surface. But by this point, we're also starting to shut down precipitation. So basically, all of the snow that did fall just went into saturating the lower levels, but very little of it actually went and made the journey all the way down to the surface. So let's go put some of these concepts that we just talked about into practice in this episode's first radar recap. So before we can dive straight into the radar data, first we need to understand what volume coverage pattern, or VCP, the radar was actually scanning in with this particular event. So there are different VCPs that we actually have control over here at the Weather Service that we can put the radar into in order to see the things that we need to see during any particular event. So during a typical severe weather event, we are going to be in what's called precip mode, one of those scans over on the right-hand side, so either 12, 112, 212, 215. Those scans are faster, but they don't have sort of the clarity and the best velocity data that you're going to get in the slower and more sensitive clear air mode. So like anything else, you have a trade-off there. In a severe weather scenario, we're going to be in precip mode because we need faster, more frequent updates. And clear air mode is the scan that you're going to use, well, just any other day if it's perfectly clear outside. But we can also use those at times when precipitation is much lighter and more difficult to see in the less sensitive precip mode. So the clear air mode scans are slower, more sensitive, and will show you a little bit more, whereas precip mode will not pick up on those lighter echoes because it's not as sensitive, but those scans are faster. So in our Central Texas radar event we've been talking about, we were using a clear air mode in order to see that very light snow and those weaker echoes that we otherwise probably would not have been able to see. So let's talk about a little bit what that means. So in VCPs 31 and 34, those are two clear air VCPs. We were using 34 during this event. The radar pulse is actually 3 times longer than normal. We're still talking very quick. It's on the order of millionths of a second. It's 4.5 microseconds long that the radar is actually emitting that energy and then listening to see how much energy is returned to it. But that scan is basically 3 times longer and therefore more powerful than a shorter pulse VCP. And that allows you to pick up more energy back at the radar from very weak echoes. So from light snow, or if we have an event with just light drizzle, that's really the only way that you're actually going to be able to see that on radar. So for this event, again, we're running VCP 34. It's longer pulse, so it is more sensitive and therefore able to pick up lighter echoes. So let's go to the actual radar here. Like we saw before on our radar tweet that we were talking about earlier, we have all of these light echoes up across North Texas, up towards the Red River. There is absolutely no precipitation actually reaching the ground in this area, despite the fact that the returns look quite similar to those down to the south. So remember, the radar is located here in South Fort Worth, and the beam is scanning up and away. So again, we are scanning immediately around the Metroplex. We are scanning below that cloud deck, below where the snow is actually sublimating and drying up into thin air. And as the beam continues to tilt upwards, as we move out and away from the radar up northward towards the Red River, we are then picking up where that precipitation exists up at 6,000 to 7,000 feet. And then we have sort of this more speckled, showery precipitation down farther to the south across central Texas. And that is actual, a little bit more real snow showers at that point. But again, this radar hole that you see over the Metroplex is not actually a hole at all, because keep in mind, the exact same conditions exist across all of North Texas at this point. The entire area just has that canopy of very thin, shallow cloud layer where all of the snow is just sublimating immediately beneath the cloud base. So again, right now we're looking at the lowest tilt. We're down at 0.5 degrees on our radar scan operating in VCP 34. So let's just take this particular moment in time And let's just tilt up on the radar to those higher elevation scans. So we're going to look up at 0.9 and then up at 1.3 elevation and then 1.8 and 2.4 and 3.1. And look what's happened to our radar hole. Well, now we actually have our highest returns right over the Metroplex. And that's because that beam is now encountering and slicing through that snow and that cloud layer at that steeper elevation angle where the radar is scanning. Whereas if we tilt back down here, we'll actually see that in the exact same spot beneath it, there were no returns at all because that radar beam is scanning below the cloud base. It's just missing that snow that exists 3,000 to 4,000 feet up above your head. So again, you have to have some background knowledge of the environment before you go straight to the radar data. Otherwise, radar can lead you astray at times, and it will give you sort of a false impression of what might actually be happening out here. So these returns up here in Wise County near Decatur, there's basically no snow associated with those at all, whereas similar returns down across Hillsborough down here in Hill County, it was actually snowing at this point, and they had some snow accumulations in the grass, even though the radar looked almost identical. This has been the radar recap for our Central Texas snow event, but we also, if you remember back in December, we had some severe weather during the week of Christmas. So let's get into radar recap number 2 and recap a very brief tornado that occurred back on Christmas Eve. For our second radar recap, we are going back to December 24th, Christmas Eve in Central Texas, and taking a look at the Central Texas radar, KGRK. And to my point just made in the previous radar recap, we first have to talk about what mode we're in and what elevation we're scanning at. So we are in VCP 12. It's one of those precipitation mode VCPs, and we are scanning down at the lowest angle of 0.5. So we're looking at our base scan right now. So in addition to all of the thunderstorms on the radar right now, and of course this one might catch your eye over in Limestone County, where we have some much stronger velocities. What you should also notice first is this sort of fine line that's draped through Lampasas over towards Killeen and then back up a little bit south of Waco. But remember, we need to kind of figure out what's going on with the environment before we can dive straight into the radar data. So this little fine line on the radar here is actually a cold front that's in the process of moving from north to south through our entire forecast area, and it's making pretty steady southeastward progress at about 15 to 20 miles per hour or so. And areas back behind that front, so anywhere up in North Texas, anywhere north of that little radar fine line here, have rapidly cooled off. There's temperatures in the 50s or lower 60s. So anywhere behind there, you've basically destroyed any low-level instability that you've had. Now, ahead of that front, and off to areas to the south and southeast, you're still in the warm and unstable warm sector out ahead of this cold front. So there's plenty of instability. Not a ton, given it is December, and we just don't have as much instability to work with usually in the cool season, but there's plenty of shear and plenty of potential for storms to be able to rotate. So our main storm of concern that probably caught your eye earlier over here just to the east of Groesbeck is definitely experiencing and exhibiting some rotation right now. From the previous scan, I kind of want you to watch how quickly this particular storm wrapped up. So at this time right here, we have some strong outbound velocities in these red and pink colors, but not anything that's too organized or strong, and these inbound velocities are pretty weak. So we basically have about 20 to maybe 22 or 23 knots of rotational velocity. That's basically the average of outbound and inbound velocities that are unfolding. In the course of just these next few minutes, I want you to watch what happens with the velocity on this particular storm. So this is just 5 minutes later, and we have really tightened up our rotation. We have outbounds directly up against some weak inbound velocities, but our rotational velocity now is in excess of 35 to nearly 40 knots. These are some 70 plus knot outbound speeds and 5 to 10 knot inbound speeds. So we're looking at rotational velocity right around 40 knots. And that's enough to go ahead and trigger a warning decision. So at this time, a tornado warning is going to be issued, and you can see how strongly this storm really wrapped up and how quickly it wrapped up. We're now sitting at well over 45 knots of rotational velocity with some 75 to nearly 80 knot outbound velocities up against some 10 to 15 knot inbound velocity. So really remarkable rapid strengthening of this particular storm, which was still located just out ahead of our cold front. So keep in mind, we can't tell exactly where this cold front is actually located. We have kind of the opposite problem that we had in Radar Recap 1, where we were scanning below the sublimating snow and the cloud deck in that example, but now we're actually scanning up and above where the front can actually be seen. So this fine line back here on reflectivity, you kind of lose it as you progress farther to the east because we're scanning up and above where that frontal boundary can actually be seen. So you can just kind of vaguely continue it off to the east and make your best assumption that you can about where it is, but it's pretty clear that this storm is still out in the open warm sector by probably at least 10 to 15 miles ahead of the front actually arriving. So until that happens, it's got access to surface-based instability and is certainly capable of producing a tornado. So we're going to continue this for about the next 15 minutes or so and watch it go into Freestone County, and look how strong this rotation is able to be maintained. We have a couple scans in here, so anytime you're looking at velocity data, you always have to be a little bit skeptical if you only see something for one scan or you see a flip-flop in inbounds versus outbounds. So in this example right here, this is just a case of the radar not unfolding the velocities correctly after it's trying to process what exactly is happening. This is, of course, a very turbulent area of the storm where there's a lot going on. You have very strong velocities, and it's actually not unfolding those correctly. So if you see something flip-flop from one scan to another, those velocity data, or that velocity data should be, you should be skeptical of it. We'll say that. So clearly some bad inbounds here, but still very strong rotation. We still have 35 to 40 knots of rotational velocity as the storm moves into Freestone County. So it's actually at this point, about right now, where the storm finally produces a tornado for the first time and only time in its life cycle, now that we are in Freestone County. Taking a look at the reflectivity presentation, there's nothing too remarkable. It never had a great reflectivity structure to it. There's some vague evidence of hook structure back here on the back side of the storm, but otherwise this was much more impressive from a velocity standpoint. And I just want to keep this going for the next 20 or so minutes of the storm's life cycle. It maintains some strong velocities, and as we head into the I-45 corridor, but the storm has actually stopped producing a tornado. It's around this time where the front is probably catching up to the storm. If we go back and look at our fine line and kind of continue it off to the east, if we make an assumption that it's sort of continuing in a straight line, it's probably intersecting and interacting with the storm basically right now on this radar scan. And as soon as that happens, it's going to cut off all of the unstable and warm and humid air that's flowing into that storm and supplying it and being able to maintain that tornado threat. Likewise, the storm that developed back off to the south and east, that's also in the process of becoming cut off by the front as well. You can see that the front is probably either right near or probably just through these supercells right now, and that has essentially eliminated the tornado threat. We've got north winds at the surface with temperatures rapidly falling down into the low 60s and the 50s, and there's no instability left to actually support any sort of tornado threat whatsoever, and we'll go ahead and allow that tornado warning to fall off. Likewise, if we look back to the west, you might, again, in the absence of checking what your environment is, if you just sort of become focused on this one supercell back here to the west, this looks really impressive. You've got a really nice hook structure on this storm back here in Coryell County, and it's clearly got some rotation to it. But is there any concern for a tornado at all? There's absolutely none. It's well behind the boundary. The surface temperatures are probably in the mid-50s back here with a light north wind. So aside from being a hail producer out of the storm's hail core aloft up above the frontal inversion, this storm has absolutely zero threat to produce a tornado, despite initially, if that's all that you glanced at by looking at the radar, you'd be very concerned about a potential tornado threat if you ignore the fact that the boundary is already through and cleared where the storm is. So while this severe weather event was about a month ago, we're not going to have any shortage of severe weather coming up right around the corner. We're heading into severe weather season. It's going to be here before you know it. So one thing that we want to talk about today is how you can become involved with our Skywarn Storm Spotter team and contribute to the success of our radar and warning program. Joining me today to talk about Skywarn is our warning coordination meteorologist, Jennifer Dunn. Jennifer, thank you so much for coming on to our Weather Spotlight segment for today's episode. How's your January been going? Have you enjoyed the cold weather, or are you somebody that's looking forward to the warmer springtime temps around the corner here?
Hey, Matt, long time no see. Thanks for having me on today. I have enjoyed the colder weather. I have enjoyed the fact that we have had some snow and not our typical ice events instead. But I think I'm ready for a little bit warmer weather right now, at least for a little bit before the cold comes back in. So I kind of roller coaster in between, but looking forward to warmer temperatures coming up here in a little bit.
Yeah, definitely. Always nice to see a little bit of snow, I guess. But of course, with the transition back into warmer weather also comes the return of chances for thunderstorms and severe weather as we head deeper into the spring coming up in the next several weeks here. So, of course, as our warning coordination meteorologist, you spearhead the Skywarn Storm Spotter program at our office each and every year. So, for those that haven't heard about it before, what does it mean to be a Skywarn Storm Spotter, and how can people become involved with that?
That's a great question, and it's perfect timing because we just started our official Skywarn classes for the year. So we start them in mid-January. We run them through mid-March. So what are they? Was the first question that you asked. And this is essentially our way to get out in the community and educate them on severe weather. So while the official title of the program is called Skywarn, and that's what you'll hear across the country at other weather service offices, here locally in North and Central Texas, we refer to it as a severe weather education class. And hopefully that kind of clarifies what we're trying to do here. Educate you on severe weather threats, hazards, and what these storms look like so that hopefully you can keep yourself safe whenever severe weather does threaten in the area. Now, the secondary purpose of it is to train citizen volunteers to be our eyes and ears on these storms and safely report to us when they can of what is happening with the storms, what they're observing, what size hail, is there rotating wall clouds, funnel clouds, and tornadoes, or any type of wind damage. So while our meteorologists are back in the office working the radar, analyzing it, sending out information, we need those citizen scientists and volunteers to be our eyes and ears and report back to us what they're seeing so we can create this 3D picture and give everybody the best information, the best warning information, so they can take appropriate actions and shelter when these dangerous thunderstorms happen in their area.
Yeah, those are great points, Jennifer. And yeah, we've talked about on the podcast before. We dive into the data here, of course, the radar, satellite, and all of this more science standpoint that we have. But there's sort of this missing piece sometimes of actually trying to get information about what's actually happening. We struggle with trying to match up what we're seeing on radar versus what is actually happening out there. And we really don't necessarily know that until our spotters become involved. So it's such a critical aspect of our warning team to be able to accomplish that and truly know what's going on, despite having all that data. So when it comes to getting involved with this program and attending one of these classes, what kind of options do folks have? Are there virtual options if people aren't able to attend one in person, or if there isn't one near them?
Yes, we do offer a combination of in-person and online classes. So for the basic class, which it's not necessarily basic, but it's going to go over the basics of storms and how to report to the National Weather Service. We offer those in-person classes spread out at various counties around. We have about 19 classes left. And then we also will have 2 virtual options. And you can find the link to register for those virtual options on our Skywarn schedule. For the in-person classes, you actually don't have to pre-register. You can can just show up at those classes, even if you're not a resident of that county. So we have the online, and then we have the in-person classes. And we really encourage you, if you can, to attend an in-person class near you, because that gives you an opportunity to interact with the meteorologist and ask questions and kind of have that ability of being there with the speaker and asking and answering questions and hearing from others also. And like you pointed out, I really do just want to highlight again what crucial role our trained spotters do play, because as you said, Matt, we have some great tools like satellite and radar, but they do have their own limitations. And so in order for us to really understand what's reaching the ground, which we have to remember, the radar doesn't sample the ground, we need that ground truth from our spotters. And so even if our quote trained spotters don't officially become part of a group operations, just the fact that you are a resident of North Texas who has this training about what storms look like, what these various risks and threats are, and how to report to us really helps us kind of build that integrated warning team, like you said, sharing that ground truth information so we can make critical decisions at the National Weather Service of, well, should we even continue this warning? Has there actually been any hail? It looks like a tornado, but is it actually on the ground? We need that ground truth. And so we encourage people to come to these in-person classes. And if they can't, attend our online classes with those registration links on our Skywarn page.
Yeah, those are all great points, Jen, and plenty of ways to get involved. And sort of following up on that, is there any sort of prerequisite to attend one of these? Can anybody attend and be a storm spotter? And most importantly, are they free to attend?
Yes, they are free. There is no cost to attend. They are open to everyone of all ages. We have kids in elementary school that come and attend, and then we have people who have been coming for 20, 30, sometimes even 40 years. So kids of all ages, adults of all ages are welcome to attend. Again, you don't have to be a resident of that county to attend that class. You can simply show up and receive the same education and training, whether you are an elementary school or a little bit older than that. And again, like you said, no cost to attend. Just show up or register online.
Perfect. So we've already had a handful of classes take place so far this year, since we try to get these in during the colder times before we get too busy into the spring months. So about how many classes are left? I guess we can also take a look at the schedule here in a minute too. But how many opportunities are there left for people to attend? And also, will there be any advanced classes this year, and what exactly are those?
So our in-person classes, I think we have around 19 or 20 left between now and through mid-March. We kind of stop right before spring break, like you said, before we start getting into peak severe weather season. So about 19, 20 in-person classes. And then we have the 2 online virtual basic classes. And then this year we are bringing back the advanced classes. We're going to do that a little bit later after that spring break, kind of in that late March time period. Those are going to be online only though, so that anybody in our 46 county coverage area can attend. So they will both be the exact same presentation, so you only need to register for one. But we will have those 2 online advanced classes. Right now, I don't quite know what the topics are going to be. Sometimes we take a look back at a case study. Sometimes we look at new technology that's come out and kind of share how the meteorologists use that. Sometimes we do some radar analysis, and we'll kind of do a combination of all of that since it's been a few years. But again, these classes run about 2 hours each. So when you're signing up for them or you're planning on going, make sure that you're planning to be there for about 2 hours, including the online classes also. But don't worry, we'll give you a little bit of a break in between, because we'll need a break from talking too.
Yeah, that all sounds great. Well, Jen, thank you so much for joining me today. We'll be sure to link all of those pages that we talked about, the schedule, as well as some other resources that we have online. I think there's still a recorded class even from a previous year if you're just interested in maybe checking out the Skywarn program out of season if we're not having classes at the time too. So I guess that's another option for people to go ahead and start to, or at least get a head start even before they're able to attend one in person too. So thank you so much for being here today, and maybe we'll see you out at a couple of Skywarns here in the next few weeks.
Yeah, that'd be great. We look forward to seeing everybody. We thank them for their interest in weather and for being our eyes and ears, but they have to remember to be safe during that time. You've got to take shelter first, and then you can make a report to us. But come join our class, learn about storms and threats, and learn about how to report to the National Weather Service. We will take all the help we can get.
Thank you again to Jennifer for coming on and talking with us today. Be sure to check out our Skywarn page. We hope to see you at one of our Skywarn classes here in the next month or two. And we'd love to have you as part of our Skywarn program to help contribute to the success of our radar and warning program. Again, the link for that's down in the description. So be sure to check that out as we head into some more active weather. And we've got no shortage of active weather coming up the rest of this week. Looks like a pretty good system that's going to be impacting us, and we're going to take a look at least one particular model here and what it's showing for the rest of the week. So you might remember from a couple of our previous podcasts that we're basically going to descend in a clockwise direction as we look from the top left and then around down to the bottom left for the elements are that we're actually looking at. So we've got this belt of strong winds and the jet stream up here. Up at 35,000 feet. We have our main feature of interest is going to be this upper low that's beginning to cut off across the Four Corners region over to the west. And then down in the low levels, we have south winds that are supplying the area with plenty of Gulf moisture, and it's going to result in overcast skies and just kind of cloudy and dreary conditions through most of the remainder of the week, while we increase our chances for showers and thunderstorms as well. So if we move forward in time here, you can see what happened to our mid-level cutoff low. It's deepened further. It's moved farther south. It's now basically over Arizona, moving even farther south towards the Baja. We have a steady southward supply of Gulf moisture with south winds just continuing to pump in higher humidity. And our model is starting to produce quite a bit of rainfall anywhere from New Mexico all the way through Texas and over into Arkansas as lift is on the increase ahead of this low pressure system. So going another 24 hours, we are now into the day on Thursday. We can see that we have a lot of upper level and mid-level divergence. So you have basically spreading out of your wind fields ahead of this upper low, which is increasing lift. You also have a lot of low-level warm and moist advection with warm and humid air streaming into the area still with those south winds. And our model is dumping out heavier rain now at the surface, anywhere from New Mexico and through most of Texas at this time. So rain looks to really ramp up from Wednesday into Thursday. Most of the time we might be spending in the post-frontal cool sector with this sort of stalled frontal boundary that's just draped down through central Texas. So a lot of the week might be spent on the cool side with highs in the 50s and lows in the 40s for the most part, while we just keep waves of showers and thunderstorms kind of around on an occasional intermittent basis. One other thing that you'll notice at this time is that at the surface, our winds have actually gone back to the south. So as this low pressure center moves across, it's probably going to act to pull that frontal zone back northward. Well, so when that happens, we are no longer going to be in the post-frontal cool sector, but we're going to open the door for potentially a brief window of warm sector thunderstorm activity. So that's going to be something that we're going to have to watch for potential severe weather probably late Thursday and on Friday, depending on the exact speed and timing of this low. As that warm sector opens up, we're going to have more surface-based instability and, of course, plenty of wind shear with such a strong storm system coming across. So we will have to keep an eye on that for an episode of severe weather as we close out the month of January and move into February. So there is one other thing that I would like to talk about with the model data and sort of another way that we're able to view some of the same information, and that is by looking at an ensemble of model data. So we don't just sort of have 2 or 3 weather models to pick from. There's actually entire ensembles ran with slightly different initial conditions and different methods and schemes of how they solve all of the math and physics problems that go into them to try to give us a forecast. So what we're looking at here on this chart is actually 80 different ensemble members. Each one of those members is here on this vertical axis, so each one gets its own horizontal line, and we're moving across in time as we go from left to right. So all of this green here, so we're looking at basically accumulated precipitation that these models are producing. So These green boxes here indicated that all of these models were producing rain. And this was valid for Sunday and Monday. So this was our little bit of rain that we had during the daytime Sunday before that came to an end during the afternoon and evening and gradually tapered off. And then we had some dry time to begin the week, Monday, and then most of today as well. But you can see what happens here between Wednesday and into early Friday. We've got this really strong signal of some heavier rainfall amounts as we get into like these yellow, orange, and red colors here. So basically, every single one of these 80 model members is producing heavy rainfall during this time. So it increases your confidence that it absolutely is going to rain later this week. No question about that. The big question mark for us that we still have to always narrow down is exactly how much. And that question always remains difficult, but being able to look at 80 different ensemble members sort of gives you a spread and a window of expectations that you can have, and you can sort of see what some of those extremes are and what those outliers are, and try to pin down what a most likely scenario might be, which is probably at least a widespread 1 to 3 inches for most of the area, as well as a worst case scenario where some areas could easily probably pick up 4 to 5, even 6 inches of rainfall as things evolve here over the next few days based on some of these model outliers. So it gives you a nice expectation and a whole basically envelope of possibilities that you can use to refine your forecast. So confidence very high, of course, in rain through the late week period. And then you can also see how sharp and abrupt this cutoff is for rainfall. We only have like 2 out of these 80 models that are actually lingering rain into the upcoming weekend. So confidence is also high that we're going to dry out in time for the weekend. We can also look at different elements here. So let's, instead of just looking at rain, let's go over and let's take a look at temperature. So again, we had each one of these models is producing a temperature forecast too. So we can see in these cooler light blue colors, this was one of our cooler mornings earlier this week when we had lows in the 30s. But after that, we really stay pretty mild through the rest of the week. These temperatures are all in the 50s and 60s with lows maybe in the 40s by the end of the week. But even into the next week, through the first half of next week, some of these models have highs in the 60s or even lower 70s. So there's not a whole lot of signal for another strong cold front or anything like that within the next 7 to 8 days at least. Looks like we stay pretty mild. All of our precip is going to fall as rain. No chance for any snow. But do keep up with the forecast the next few days because the threats for heavy rainfall, like we talked about, as well as severe weather are always evolving. This is just what I have at this particular moment, but we are always working to refine the details, so be sure to head over to our website to keep up with the latest forecast. Do also check out the Skywarn webpage too, and we hope to see you at one of our Skywarn classes this spring. We'd love to have you help us out as we move into severe weather season. We always need your reports. Keep your questions coming for the Q&A segment. We always need more of those, and we'll be addressing more of those as we move into more frequent podcasts, hopefully. That's going to be all from me. Don't forget your umbrella the rest of the week, and we'll see you next time.